All right, so now we're going to talk about the midpoint formula. And then again, everybody thinks this is a formula, but it's really not a formula. It is a formula because you're looking at it, but let's understand what the formula means, okay? So if I have, let me see how to explain this the best. Okay, I know how. So I'm going to turn this into a triangle. Okay. And if I know how long the line horizontal to the x-axis is, and I know how long the line parallel to the vertical axis, the y-axis or the vertical, if I knew the length of that and I wanted to find the middle, I can average them, can't I? I can take, whenever I want to find the average of something, I take I take all the numbers, I add them up, and I divide by the number of numbers I have. But here, I just have two numbers, right? I have an x1 value and an x2 value. And then this point right here, we'll call this y1 because the point x1 comma y1, right? I go out to x1 and up to y1. And then we have another point out here, and we'll call this y2. And then if I add, and then this point right here would be x2 comma y2. And if I want to find the middle of both of these lines, the new ones I just made from my triangle, can't I just take the average? I can add the two values, the two endpoints, and divide by 2. I can add the two y values, divide by 2. That gives me the middle, okay? And that's really what we're doing for midpoint formula. So yes, there's a formula, but if you notice, this is the average of the 2x values at the end, right? And then this is the average of the y's. Okay, and so now I just add them, divide by 2. So that's why it's called the midpoint formula. So let's do this problem. It says find the midpoint of the segment from -3,2 to 4,6. And again, let me draw a picture instead of just using a formula. So -3, +2, and that's my first point. I'll call this point x1 comma y1. I'm going to call this point x2 comma y2. So now I'm going to graph that point, which is 4 comma 6. So 1, 2, 3, 4 in the x direction, and 1, 2, 3, 4, 5, 6 in the y direction. So that point here, I'll just make it in purple, is right here. And basically, here's the line that connects them. Okay? But what I really want to do is find the middle. And I don't know what the number is at the middle, but let's say that's the middle of that line. So again, if you do it the way, I just showed you, what I'm going to do is I'm going to make that triangle that I was talking about. And those are the two endpoints of the line, right? Actually, -3. I didn't do that right. I'm so sorry. That is 4, 6. This is not -2. And that is definitely not the midpoint. So again, I'm sorry about that. So we go -3, +2, and I am out here. Again, my apologies. I don't know where I got that number from. So now here's my line. And somewhere in the middle here, I mean, I'll say this is the middle. Let's say that's the midpoint, right? And I want to find it. Well, again, I can make my triangle. And of course, you don't have to do all this work. I'm just showing you so that it makes sense, you understand it, and it won't be hard for you to memorize that formula. Okay, so again, I have this point and this point. This is -3 and this is 4. And if I want to find the distance between those two, I can add them, right? Or I'm sorry, I can subtract them. So I know the difference between those 2 points is 7. Now, is that helpful? Well, let's see. If I use the formula, which is I add the two x values and I divide by 2, and then I add the two y values and divide by 2, what do I get? I get 1/2, comma, 4. Okay, so that is what we're saying the midpoint is. Well, that kind of makes sense, because if the distance between here and here is 7, right, which we just counted, we can just count it 1, 2, 3, 4, 5, 6, 7. Or another way to find the distance between 2 points is to subtract them, right? So 4 minus -3 becomes 7. Half of that is 3.5, isn't it? So, which means I'm going to go 3.5 this way. So this is 3.5. And I'm going to subtract 3.5 from here, which gets me to 1/2. And that's my x value. And the middle of 2 and 6 is 4, right? It's 2 from, it's 2 above the 2 and 2 below the 6. So this would be my midpoint. And again, I'm not trying to say you should draw these triangles. I'm just trying to show you how it works. And the midpoint is, again, we take the average of the endpoints, which means I add them up and divide by 2 for both the x and the y separately. Okay, so hopefully that makes sense. If it doesn't, you're always welcome to come. You're always welcome to just shoot me an email, ask me a question, come to my office hours. I'll explain it in more detail. But I don't really like formulas that are really like, if you have too many formulas, you won't actually know what to do. So again, we have this thing called the distance formula, but the distance formula is really not anything that you haven't seen before. You just haven't used it. So for example, let's say I have a point here. I'll call it x1. I'll call this point x2. I'll call this point y1. And I'll call this point y2. And here, I'll start my line here, and it's going to end here. And I want to know the length of that line, not the midpoint, because the midpoint, we just add those 2 points together and divide by 2 for both the x and the y. But that's kind of a hard formula to remember until you realize where it comes from. So again, I'm going to make a triangle and I'm going to connect these points into a triangle. And if I want to know the length of that red line, well, I just made a right triangle, right? And since I made a right triangle, and if I call this A and I call this B and I call this C, most of you have heard this before. This is just the Pythagorean theorem. Remember, the Pythagorean theorem says I have a squared plus b squared equals c squared, right? Well, let's kind of figure out what this all means. Well, a is the distance between x2 and x1. And if I want to know the distance between two numbers, I just subtract them, right? Like if I want to know the distance between 1 and 4, is the value is 3, because 4 minus 1 is 3. If I want to know the distance between -2 and +3, I still subtract. 3 minus -2 becomes 3 plus 2, or 5. So I'll always know the distance between the two values, because A, here, let me write it here, A is going to equal x2 minus x1, right? The bigger number minus the smaller number. That gives me the distance between those two values. And B is going to equal y2 minus y1, the distance between those two values. And if I plug them in here, then what do I get? I get x2 minus x1 squared plus y2 minus y1 squared equals c squared, which is what I'm trying to find, is the length of c. But the Pythagorean theorem actually uses lengths. So the length of A squared plus the length of B squared always equals the length of C squared. But I want to know just what C is. So how do I do that? I take the square root of both sides. And when I do that, I'm going to flip the equation around. So I have C is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, right? And you might say to me, if you remember you've done it before, well, what about plus or minus? Well, true, there is a plus or minus, except distance is always positive, right? We talked about this when we were doing absolute value. The distance is always positive. I don't go a mile in one direction and then tell somebody, oh, I have to go a mile. And then if I'm coming back, I don't say -1 mile. It's still 1 mile. We talk about distances always as positive numbers. So if it wasn't just that we were looking for the distance, we would have to put plus or minus. But since we're looking for the distance, it's just positive. So you can see that's how I get the distance formula. So if you don't remember the distance formula, make a triangle and do the Pythagorean theorem. So for example, let's say I don't remember, I'll do it both ways. So here I have A equals -1, 5. So we have our point, -1, 5, okay? -1, 5. And then we have another point at 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is -5, and this is 4. And our other point is down here, right? And we want to know the distance of that straight line that goes from one point to the other point. So let me start with, I'll start with doing it out with using the Pythagorean theorem, and then I'll also show you how to use the distance formula just by memorization, because I know some of you like to memorize things. So whichever way you like, feel free to do it. So again, I make my triangle. Right? And if I want to know the distance between, here, let me get it here. If I want to know the length of this line, and again, we can call this A, I can really just count it. So if I count it, I'm at -1. So Here, let me see. So here's 1, 2, 3, 4, 5. So A is equal to 5 using the Pythagorean theorem, right? And then I can count the Y values. I'm starting here at -5 and I'm going all the way up to +5. And if I count, what I'm going to do is I'm going to find that distance, this distance right here is, we'll call it B, and it's going to be 10. You can count starting at the bottom. So like, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So I just counted, I could count it, or again, I can just subtract one from the other and I'll always get the distance. So if I want to actually do this work now, I know a squared plus b squared equals c squared, where this is c, which I'm calling the distance. Okay? And a squared equals 25. B equals 10, so b squared equals 100. And that equals c squared. So c squared is equal to 125. And then I have to simplify 125 because I'm going to take the square root of both sides, right? I take the square root of both sides, and I'm going to get c is equal to the square root of 125, which is equal to the square root of 5 times 5 times 5. You can factor it, and you'll see there's 3 5s. For every 2 that are under the radical, because there's a invisible 2 here, I can cancel those and take it outside of the radical and then multiply by the square root of 5. So the distance from one point to the other is c, which is 5 times the square root of 5, or we can call it d, or we can call it whatever you like, but that is the distance. Okay? Very good. Now I'll do the same exact problem, just using the formula. So again, if I know the formula, which is the distance, and now I really can remember it pretty easily because I know it's the square root of the difference between the x's squared plus the difference between the y's squared. And it doesn't matter which one you call 1 and which one you call 2, as long as you label it. Okay, so like if this is 0.1 and this is 0.2, that's fine. Then x1 is -1 and x2 is 4. I could change it and make it the opposite, because the only thing that's going to happen is I'm going to get a negative number, but when I square it, which I'm going to do for both of these values, it's going to turn positive anyway. So again, it doesn't matter. So now we have the square root, and then we have x2, which I'm going to use b as x2. So I have 4 minus a, the x for a is -1. This is squared plus y2. So y2 is -5. Let me do that. Sorry. So this is -5 minus, and y1 is +5. So I'm going to just put a +5 in there. I square it. This is equal to the square root. And again, 4 minus -1 is 5. 5 squared plus -10 squared. And again, I said it doesn't matter, right? Because this is really the square root of 25 plus -10 squared is still +100. which is equal to the square root of 125, which is exactly what I got. And then I already showed you how to simplify that, is 5 times the square root of 5. If you're having trouble with any of these things, please let me know. Come to my office hours. I'm happy to help you if you need help. If those office hours don't work for you, again, just shoot me an email. I can't come at between 3 and 4:30. I have a class. Can I meet you another time? And if you could send me your availability, that will really help. And then I can shoot you back an email and say, yeah, how about if we meet at 2, if that's when you're available. So I'm really flexible. I still will always have my office hours from 3 to 4:30, but I will add extra office hours if that's what's needed. And this should get you through 2.1. Have a great day.